Hi guys, moving back to this paper we started in the last clip, and don't forget it's free to subscribe. Of course, we're looking at Unit 11, Sustainability in Construction, and it's a sample paper which we have model answers for, some of which you can find, I think, online. Okay, but we'll be looking at some of the model answers and the details. But this second part of the paper, this is in a set extended question here. We're looking at two different developments, and we're looking at related questions to their construction. Okay, so let's look at the two building structures and see how we do with that. Okay, don't forget this is the Shed Hacks version of this revision. There you go, Shed Hacks. Okay, right, so you can see here this is a 1960s stroke 70s building type of construction. It says 1962. The design actually extends right up into the 70s and goes back towards the 1950s. And this sort of concrete structure was very common in those years, around those 2 decades. Concrete structure reinforced, of course, with steel, and then infill with brick panels between floors. Quite often they had a car park underneath, and access was usually actually relatively good. However, certain modern features wouldn't have been included in this building, and the use of solar energy and heat or solar saving systems wouldn't have been included. They had large windows. Usually they were what we'd know as crittle windows, which are aluminium or steel framed windows. Normally single glazed, and I think it may even mention this on the notes here. So read the notes. It talks about insulation, lightly insulated. It uses low energy halogens, which have been obviously added in at a later stage. It would have been fluorescent strips beforehand. Has an old gas-fired boiler installed 20 years ago, has no air conditioning. It's an inner city location, and the area is quite built up, and there's quite a large area of hard standing stroke pavement area around the ground floor level. It's made, it says, from brick cladding, which we can see here, but it is a concrete reinforced structure, and you can see these on the external face here. Okay, then moving on to this building, much more modern structure, made in 2012. The design of these sort of buildings have been around for probably about 5-10 years prior to this age, and the more modern designs show insight into saving energy, and actually a more careful use of materials. Now, what does it say? It's a steel frame, so it's not a concrete reinforced structure. It's clad with glass, as you can see, so the outer layer is glass. More than likely, it doesn't say double glazing, but it probably will be double glazed. Does it say that? Yes, it does say double glazed. Aluminium windows, they can be recycled on their end use, or if demolished. Aluminium can be recycled more easily than steels in some ways. Windows, the windows don't open, so there must be some sort of automatic system to allow light to enter. Okay, so it uses natural light probably a little bit more effectively than this design. In here you'd have to have blinds or some way of actually stopping the light coming through in the intense sun type of days, and then conversely you may have a lot more artificial light on the darker days. But this looks like it's been designed to allow light to flood in, if you like, more easily. It contains a green roof and a recreation terrace. That's nice, recreation area around here. Zinc panelling, so the zinc panelling here, I think that's zinc panelling, although it looks like brickwork. Oh, so here's zinc panelling as well on the edge. Is maintenance free and looks quite attractive over many years. There's the green roof on top, you can see it there. Okay, these are, it mentions terracotta tiles here, so that's clay tiles. Bit of brickwork there, I think. Yes. The building has thermal insulation within the walls, so it stops the heat being lost through the walls here in particular. The eaves detail around the roof edge are in zinc, and you can see that this zinc work is actually quite attractive over perhaps some of the older designs. Rainwater fall off prevents hardening. Okay, so demolition waste was used for filling materials. Okay, that's interesting. So the insulation used in the structure was actually used from reclaimed materials from a demolition at some point. And it is cooling and heating requirements for the building are provided. That means they are achieved by ground source heat pumps. So that's a natural way of getting heat over burning gas or oil, a more natural way of gaining heat from the ground. Okay, and it has natural stack ventilation. So that means it has a system of ventilation channels within the structure that allow the air to naturally flow round and out. Okay, so you read the questions carefully, perhaps underline some of the points, and then you can tackle the question. Now the question, or questions rather, are normally in several parts, and it's 13 marks, and you normally have a little bit more at the back, which allows for what we call extended writing. Okay, both buildings have sustainable features, and it mentions outline 2 sustainable features. Okay, right, so I think you could mention aluminium can be recycled. You could also mention the fact that it has heat pump type heating. Okay, right, okay. I think that helps. Aluminium can be recycled. I think they're good. Yeah, that's good. Okay, part B, explain how aluminium sunscreens in the building contribute to sustainability. Okay, so aluminium, okay, okay. Firstly, they're recyclable. If ever reused. They reduce heat and light levels when required. So you can automatically adjust them. And let's have a look at what they're talking about. These aluminium panels here, and the louvers actually change to allow heat from the sun to enter and light, and vice versa. Okay. Okay, so the screens are usually automatic. Can be made automatic. I made a point of putting a capital letter on there. Can be made automatic for differing solar levels. Solar meaning sun levels. Sun levels. Okay. And to some extent, they also provide some shelter from the weather too. Okay, so these screens, they also provide some resistance to wind, rain as well at the lower levels. Okay, so it's all helpful to keep off the cold, and also it in some way helps keeps the windows cleaner, doesn't it? Okay, good. Now moving on to question 11. An office block like building 1 here is being demolished. State how each of the materials can be disposed of sustainably. Okay, so how can you get rid of these materials sustainably without damaging the planet even more? Okay, well, one of them could be once, and it talks about the bricks here, actually gives you 2 materials. Once cleaned, can be reused. Oh, or as fill material for foundations. And sometimes this is called hardcore. Okay. Right, just put my glasses on a bit so I can see that. Okay, and glass. Well, glass can be reused. Not necessarily recycled in this case, but reused into new glass. Yeah. Or even into sand. So what I'm saying is they add crushed glass and mix it in with sand, and they process it to make insulation, and then processed to make insulation. Okay, or other building materials. Okay, right. Now 12. Give 2 reasons why the collection of rainwater in building 2 improves sustainability. So they collect the rainwater here, and they're got a green roof here. Why does it help support sustainability? Right, well, certainly improves it in some way. Well, common sense answer, less mains water, that's water coming from the tap, is required. Okay, and it's required for watering, for plant watering. Okay, and of course less drainage is needed because you're using it. So we can put that down as another point. I know they're only asking for 1. Less drainage is needed, therefore, because you're using some of it, aren't you? So it's sort of an outcome from this point here. And I'm going to put another one here. Less water runs off the building. Okay, less water runoff because some of it's been again consumed, used for other purposes. And of course there's another one. So we've got 4 points actually. Can be used for watering. Okay. Oh well, actually, so yes, we've mentioned that there actually. Anyway, points coexist. 13. Explain 2 advantages of using a green roof for an office building. Okay. Why are we going to use a green roof here for an office building? Let's have a look. Well, the obvious sort of answers I think include, and write in full sentences if you can, I know I'm rushing a little bit, green roofs permanently contain moisture. Now remember, we're looking at disadvantages. These are negatives. Okay, these are negatives. So if you're permanently containing moisture, this can cause long-term long-term problems. Now, when I say long-term, we're talking over, say, maybe 20, 30, 40 years. And what can happen is that you have problems with moisture getting into the building eventually. Okay? And I'm going to put this comment: unless very carefully drained. So if you don't drain and keep this area very carefully maintained, you could end up with moisture that's collected here going into the structure and damaging the actual structure of the building. Okay, starting with the roof structure. Okay, so they're good points. And of course then that causes ongoing maintenance issues. So you're going to have to make sure you've got maintenance every year to check and correct any potential problems with water or moisture perhaps collecting on the roof. It could be blocked drains or all sorts of things. And the other big issue, structural issue, massive weight issues to design for. Now, what this means is the structure will have to be made even stronger than perhaps it would otherwise be. E.g., larger structural components, and that could be beams, okay, and columns. Okay, the beams and columns, okay, holding up the structure might need really being made much larger. Made much larger because of it. Right, good. Okay, and I think on the last question here, if I move this over a little bit. Okay, let's have a look. Right. Compare the carbon footprint. This is an important aspect we need to understand. The carbon footprint of two buildings, or of the two buildings during the operational phases of their life cycle. Operational is a term which means in life, during its life. During life. Okay? The operational phases. When it's been actually operated within. Right, okay, now these are some big issues. The carbon footprint is any energy that's used as a result of the building existing. Anything at all that's been used while it's in existence. So, let's have a few bullet points which you can extend, I'm sure, or certainly discuss. Building 2 has larger areas of grass to maintain. So this is an ongoing thing, and this will be forever. Yeah, you'll have to maintain those grass areas forever. Okay. So, higher embodied energy over time. Okay, so if you're going to maintain a building like this one, okay, or these sort of grassed areas, these areas will have to be kept very, tidy, and the green roof has to be kept tidy. And this all takes energy, lawnmowers and sprinkler systems perhaps, but it has to be maintained. So the energy used in doing so has to be considered. There's large areas of glass to be cleaned as well. There is here, but I'd say even more so here. Okay. So let's move on a bit. Okay, so let's put this on. Aluminium screens keep building 2 cooler. However, 2 commas, aluminium is expensive to process. Okay, from aluminum, which is the ore. Okay, so that's expensive. It's expensive because it uses high levels of energy for that processing. Bit of research there. Research that point. I would research how aluminium is processed. Very expensive. Okay. Building 2 has high standards of insulation. Okay. So building 2 has high standards of insulation. Now this is interesting. This is a good thing, but initially, of course, it's all more materials. Long term good. Initial costs are high, and also more materials are used. So it's a mixture of good and bad. Long term, it's great, it's insulated, as long as it's safe insulation. But initially, you use a lot more materials. Okay. Building 2. Let's have another point. Building 2 uses heat pumps, and that's a great thing. Okay, and they call it ground source, e.g. ground source heat pumps. Okay, ground source heat pumps. And of course, building 2, lots of good things about building 2. Allows greater control of light levels from the sun. Really important. Now you could extend this even further. There's many other points. Let's have a quick look. Okay, well, the steel structure here, in some ways, although it's to do with the construction, you could say at the end of its life can be recycled more easily. But I suppose they're talking about during its life, so that's in operational phases. So the ground source heat pumps for heating is good. The louvered windows are great. It saves energy, and you can control the heat levels inside. The use of certain materials for insulation is good in many ways. It prevents heat loss, and therefore that saves heating costs. What else? The footprint, these all sort of things. So I suppose, you're using less fossil fuels if it's natural heat being used from the ground, from the heat pumps. So that's a great thing. But perhaps there's some other things there we could think about as well and add. But I've run out of time now. Perhaps discuss some extra points with your tutor, and could do a little bit of research as well. sometimes it's given away in the answer. Double glazed windows. I mean, that's a good thing, isn't it? That saves heat as well. It's orientated towards the south. So let's put that on. Here, let's put that on. South facing. Whee! Brilliant. Allows the sun for most of the day to be collected, or the heat from the sun. Anyway, I hope that's been useful. I always go through your paper afterwards, see how you've done. Go through the various points. Check you've read the question correctly, of course, and look at the key terms. Ensure that when you're reading your points, you're underlining some of the most important points, as we try to, like thermal insulation, the green roof, the zinc panelling, the recreation area, the use of aluminium sun screens, the steel frame, cladding glass, terracotta tiles can be recycled again. All right, use of demolition waste for the fill materials underneath the ground. Okay, that's what we're talking about. Quite interesting looking at these different structures, I think. And one actually, you could do another set of questions on, because you actually compare the type of structures used and why certain structures are perhaps more commonly used now. E.g., why is a steel structure used over a concrete structure? Anyway, look up SUDS, Sustainable Urban Drainage Systems, you've got there. Look up, I think the embodied energy, I think that's a good one to look at. Right, good luck guys. So that's the end of that paper, and I hope it all goes really well for you. Okay, thank you very much.